Welcome to our channel. In this session, we are going to discuss about single source shortest path problem in greedy approach. So for that greedy approach, the algorithm name is Dijkastra'S single source shortest path problem. What is the problem? Simply the problem is they are given a graph. Assume whatever it is, they are given a graph. In that graph, consider one vertex as the source vertex. Consider one vertex as the source vertex. Your aim is you need to find the shortest path from this vertex. Suppose assume A, B, C, D, E, F. Assume A is the source vertex. What is your aim? You need to find the shortest path from A to B, shortest path from A to C, shortest path from A to D, even though there is no H, A to E, A to F. That is single source vertex. From that vertex, you need to find the shortest path to all other vertices. This is your aim. Now your graph consists of some weights or distance or cost, whatever it is. Based on the cost or weight, we are calculating that shortest path. We are calculating the shortest path. Now, step by step, I will explain one example along with an algorithm. Single source of. Assume one vertex is the source vertex. Yes or no? Yes. Assume S is the source vertex. Now, they are given a graph to you. So, the graph is converted into some adjacency matrix. We already know. But here, there is a weighted graph converted into some weighted adjacency. If there is an edge, write the corresponding cost. If there is no edge, write down the value as infinity like this. Assume cost. This is my adjacency matrix, cost adjacency matrix. Now, n. Assume a variable n. N specifies the number of nodes or number of vertices in the given graph. Number of vertices in the given graph. Okay. Coming to the algorithm, you already know what is the cost. This is common. Cost 1 to n, comma 1 to n. The cost. Now, here I am using assume visit is the name, visit of S is equal to true. Here my meaning is source vertex. S is the source vertex. The source vertex is visited. Source vertex is visited. Now, consider this is the graph A, B, C, D, E. Assume this is the graph. Your aim is you need to find the shortest path. You need to find the shortest path. 2, 3, 4, 5, 1, 6. Whatever the values. Now, next step. My source vertex is visit. First step is write down the direct distance from source vertex to remaining all other vertices. What is the distance from A to B? 2. Distance from A to E, 1. Distance from A to C and A to D, there is no direct edges. No direct edges. So, for I is equal to 2 to N. So, already one vertex is visited. For all the remaining vertices, I am using a term DIST. Remember the term? DIST of I. What is the meaning? It specifies the distance from source vertex to vertex I. For example, DIST of C or DIST of B. What is the meaning? DIST of B means fixed the distance from source vertex to vertex B. DIST of D The distance from source vertex to vertex D. So now how we are given the value? Simply cost of S comma I. Yes or no? S is the source vertex. Suppose I is equal to 2. Assume the vertex B. What is the distance of B? Cost of S comma B. That is in the matrix source vertex S, destination vertex B. What is the value? That is the value. Now first two step is completed. So in the first step, I am given direct values from the source vertex. Okay. After that, what is this is fixed. After that, you need to select one more vertex. You need to select one more vertex with minimum cost. My program is single source shortest path. You need how minimum, that is A to B, the value is 2. A to E, the value is 1. A to D, the value is infinity. A to C, the value is infinity initially. If there is a direct edge, we are writing the value. If there is no direct edge, we are writing their infinities. Now, my next step is for I is equal to 2 to n minus 1 to, that means you have to find one vertex is fixed. You have to find the remaining n minus 1 path. We have to find total I is equal to 1 to total n minus 1 path. What is the change? For select an adjacent vertices or else select an adjacent node. Why I am using the adjacent node? That is a direct edges. Select an adjacent node U. Assume the name is U such that it has minimum distance. Yes or no? That means here what is node U? What is node U? E is my answer. That means for A, you have to select one adjacent vertices such that it has the minimum distance, and one more important is it is unvisited. Minimum distance and unvisited. That is, if already the node is visited, the process is repeated again and again. That is the reason if it is unvisited. Once that particular node is selected, now E is selected. Simple thing. Now E is act as intermediate node. Here the thing is A to D, there is no direct edge. What I am doing? First I am moving from A to E and then E to D. Now you got it? One place to another place, if there is no direct link, means that place to we are moving the shortest route. From the two we are moving the destination. That is U. U is the intermediate node. Once that intermediate node is identified, now the step is for each assume a variable W. For each W adjacent to U. So my intermediate node is fixed. Now E is the intermediate node. By using this intermediate node, what are the adjacent node for E? D, B, K, some etc. etc. You have to find all adjacent node to U, and same logic. Visit of W is equal to false if the node is not visited. If the node is not visited, then we are writing the condition. What is my condition? If, here I am writing, if dist of W, what is dist of W? The direct distance from source to vertex W is greater than, if the direct distance is greater than dist of U plus cost of U comma W. Understand the meaning? So this specifies the direct distance from source to W, if the direct distance value is greater than, what is DST of U? Direct distance from source to vertex U plus an edge from vertex U to W. That means if the value of direct distance is greater than using the intermediate, For example, assume this is the direct distance, this value is 10. This value is 10. Here, this value is 4. Now, what is the shortest distance from A to E? So, here distance of E, what is the value? 10. It is greater than distance of B. Distance of B means A to B, that is 2 plus cost of U comma W, cost of B comma E 4. 2 plus 4, 6. Which one is the smallest? This is the smallest. Now, my distance is updated. Distance of W is equal to, this is the formula. The concept is very simple. Even algorithm something complicated. Close the for loops. The concept is very simple. Once we practice at least one example. The only thing is step by step we are considering the unvisited adjacent vertices. From that is considered as a intermediate. For that intermediate, find out all unvisited adjacents. So the process is repeated. First time E is acts as intermediate. So A to E B, A to E D, A to E C. In the one iteration, B acts as the intermediate. A to B E, A to B D, A to B C. Now you got the point. Level by level, we are adding some intermediate nodes. Based on that one, we are finding the shortest path. Once solve at least one example, definitely you will understand the entire algorithm in clear. Okay. Thank you very much.